Prime and composite numbers. Suppose we have 3 bass drums. They may be stored on shelves in only 2 different rectangular arrangements. In the first arrangement, we can line up the 3 drums in one row. This shows the factors of 3 as 1 and 3. We can also stack the 3 drums in one column. This also results in the factors 3 and 1. These rectangular arrangements show that the only factors of 3 are 1 and 3. When a number like 3 has exactly 2 factors, the number is prime. Now let's suppose we have 4 drums. They can be stored on a shelf in 3 ways. What are the factors of 4? In the first arrangement, we can stack the 4 drums in one column. This shows the factors 4 and 1. We can also line the 4 drums up in one row. This also results in the factors 1 and 4. Finally, we can also have 2 rows of 2 drums. The factors are 2 and 2. So, the factors of 4 are 1, 2, and 4. When a number like 4 has more than 2 factors, the number is composite.
All right, we are jumping into lesson 2, which is all about prime and composite numbers. If you just watched the video before this, you would have heard that a prime number is a whole number with exactly 2 distinct factors, one in itself. That's like what we talked about in yesterday's lesson with the identity property of multiplication. Any number times 1 is that same number. 4 times 1 is 4, 12 times 1 is 12. What prime numbers are when the only factors that a number can have are 1 and itself. There was an example from yesterday's lesson, I think it was 37, I think. 1 and 37 were the only 2 factors, so that number was prime. The other type of numbers that we were talking about today are composite numbers. A whole number with more than 2 factors. So if it has 1 itself and then any other factors, it's composite. The only number that's not prime or composite is the number 1, because the only factor that 1 has is itself 1. All right, I'm writing in orange today because I got sick of black and I wanted to do something a little more fun. Okay, so if you look down here, where it says key concepts, those are the 3 things we just talked about, those 3 definitions. So if you forget what a prime number is or a composite number, come back to this section right here, okay? Read up at the top right here. The factors of a number help us determine whether a number is prime, composite, or neither. So yesterday we worked on factorization. So now we can use factorization to help decide if a number is prime or composite. Example 1. Blair is arranging 18 cupcakes on a shelf. Find the factors of 18. Use an array to find the factors. We know that an array is a picture that sets up a number for us. So there are 3 different ways that Blair has made an array of 18 cupcakes. The first one is she has one row with 18 cupcakes in it. So 1 times 18. The second way is that she has 2 rows and 9 columns. If you count all these columns, there are 9. 2 times 9 is 18. Okay? Then the last way is she made 6 columns and 3 rows. So we could do 6 times 3. So the factors of 18 are 1, 2, 3, 6, 9, and 18. When we write out all the factors, we write them from least to greatest and in order. So we don't want to put 1, 6, 18, 2, 3. We want to put them in numerical order. 1, 2, 3, 6, 9, 18. Since 18 has more than 2 factors, it's a composite number. There are more than 2 factors. It has 1, 2, 3, 4, 5, 6 factors, so it is composite. If you need to pause the screen here, pause it. Make sure you are doing these pages with me. This is page 491 of your math packet. You're doing it with me just like we would do if we were in class and I was at the front writing on the smartboard and you had your math book in front of you. Pause it if you need some more time to look at it. I'm going to move on to the next page. Okay, I'm going to clear this one off and then jump to page 492. 492, example 2. Sarah is at the park. She counts 73 kites. Write the factors of 73 on the kite. Tell whether it is prime, composite, or neither. Okay, the factors of 73 are, well, it's giving me 2 blanks, so I know that there are only going to be 2 factors. But let's talk about why. We know that 1 and 73 are factors because of the identity property of multiplication. We know that anytime we do factorization, we are always going to have 1 and the number we are working with. Now we need to think about some other ways we can factor numbers. Think about other ways that we talked about in yesterday's lesson about how you can factorize a number. You can use division, or you could use skip counting. Okay? If I skip count by any other number, will I ever say 73? No. So the only factors of 73 are 1 and 73. Since 73 has exactly 2 distinct factors, it is a prime number. It only has 1 in itself, so it is prime. If it had more than 2, it would be composite. Example 3. Tell whether 1 is prime, composite, or neither. Well, if you look back on this page and you look at our key concepts on the bottom, there is only one number that is not prime or composite. It's neither, and it's number 1. Because the only number that you can divide 1 by is 1. So let's go back to the page we're working on. Deleted my R. So it says prime, not prime. Let's put that R back in there. There we go. So find the factor of 1. Well, 1 times 1. So since 1 only has 1 distinct factor, it is neither. All right, guided practice. Tell whether each number is prime, composite, or neither. So if it's only divisible by 1 in itself, it's prime. If it's divisible by 1 itself and more numbers, it is composite. And if it's the number 1, it's neither. So 5. Well, we know 1 and 5. Are there any other numbers that we can divide 5 by? Any other factors of 5? No, so it is prime. 15. I know factors of 15 are 1, 15. I know that 3 and 5 are factors of 15. So since it already has more than 2, it is composite. I'm just going to write a C so I don't have to write composite out. Number 3, 21. 1 and 21 are factors of 21. What other math facts do I know that multiply together to get a product of 21? 3 and 7. So since it already has more than 2, it is a composite number. Number 4, 31. 1 and 31. And that's it. There are no other numbers that you can divide 31 by, or you can't multiply any other numbers together to get 31. So it is a prime number. 26. I can divide 26 by 1 and 26. It ends in a 6, which is an even number. So if I divide 26 by 2, what do you get? Well, let's do it over here. This is a great way to review some division. Actually, I'm going to go to my notes page. I figured out how I can do this without putting it all on that page. So we're doing 26 divided by 2. I don't know why I wrote my 2's in 2 different ways. Come on, Miss Volt, get it together. 2 divided by 2 is 1. 1 times 2 is 2. Subtract, oh, I forgot to write my notes at the top. I'll write them down here. Okay, now I'm at the subtract. 2 minus 2 is 0. B stands for bring down, so I bring down my 6. Now I start over. 6 divided by 2 is 3. 3 times 2 is 6. S stands for subtract, and I get 0. I have a 0 at the bottom. My quotient is full. Now, 13 is a whole number with no remainders. So is 26 divisible by 13? Yeah, 2 times 13. So 26 has more than just 1 and 26 as its factors. So it is a composite number. Let me get my pen back. It is a composite number. Now, 61. 1 and 61 we already know. Are there any other numbers that go into 61 that we can multiply together? Or are there any numbers we could divide 61 by and get a whole number without any remainders? No. So it is a prime number. Okay, what you need to do now is you are going to do the independent practice, pages 493, okay? Pause the video, do those pages, and then come back and we will work on this and go through it together. All right, we are jumping into the independent practice of lesson 2. If you have not done this page, then stop, go do it, and come back because I'm going through the answers and I want you to check your work with the answers, but I don't want it to be the first time you've seen it. I want you to give it a shot on your own and then watch this part of the video so you can check your work. All right, let's get started and jump right in. Number 7, we need to tell whether each number is prime, composite, or neither. Well, if you think about the chart we saw, let's go back to it. The only number that is neither is down here at the bottom. I'll use green. It says the only number that has one distinct factor, so it's not prime or composite, is the number 1. So let's jump back to our independent practice. What is the only number that is not prime, composite, or neither? 1. So number 7, I'm going to write P, C, or N. I'm not going to write the whole word out because I'm using this fancy board. So I'm just going to put N. 8. Number 3. What factors are there for 3? 1 and 3. And are there any other numbers we could multiply together or divide 3 by and get a whole number with no remainders? No, so it is prime. Number 9, what are all the factors of 4? 1 times 4 and 2 times 2. Since it has more than 2 factors, it is composite. Number 10, 14. The factors of 14 are 1, 14, 2, and 7. Since it's more than 2 factors, it's automatically a composite number. Number 11, 29. The only numbers that are factors of 29 are 1 and 29. There are no other numbers that I can divide evenly. I can divide 29 evenly by and get a whole number without a remainder. And there are no other numbers that work together to multiply and get exactly 29. So since it's only 1 and 29, there are only 2 factors, which means it is prime. Same thing for 41. There's no number that I can multiply with another number and evenly get 41. Or if I skip count by any number, I'm never going to get 41. The only factors of 41 are 1 and 41. So it is prime. For 13, number 13, our number is 50. If I list out all the factors of 50, I would get 1, 2, 5, 10, 25, and 50. So that is way more than just 2 factors, which means it's composite. Now I want to take this moment and talk about something. If you are finding the factors of a number, you need to list every single factor out. But in this case, it just wants to know if it's prime or composite or neither. It doesn't necessarily need all of the factors, which means as long as you can prove that there are more than 2 factors, that is good. So for 50, I could have stopped after 1, 50, 2, and 25 because that's automatically more than 2 factors, so it's automatically a composite number. Okay? You only need to go up to 4 factors to prove that it's not prime. But if it wants you to list out all the factors, then you need to list them all out. So you really got to pay attention to what our directions say, because these directions just say, tell whether each number is prime, composite, or neither. Yesterday's directions were to find all of the factors, so we would have to list them all out. All right, 63, number 14. What numbers can you multiply together to get 63? Or if I divide 63, do I get an even quotient without a remainder? The factors of 63, 1, 63, 7, and 9. 7 and 9 work together to multiply to get 63. So, since it has more than 2 factors, it is a composite number. 65, 1 and 65, and since it ends in 5, it's going to be divisible by 5. I could skip count by 5s, or I could divide 65 by 5 and get a whole number with no remainder. So it is composite because it has more than 2 factors. 79. Can I divide 79 by any number and get a whole number with no remainder? Or do I know any 2 numbers that work together to give 79 exactly? Well, the only ones that I know are 1 and 79. And since that's only 2 factors, it is a prime number. 17, 84, 1 and 84. And since it ends in an even number, it's divisible by 2. 84 divided by 2, I'm going to jump to my notes and show you this one. Let's do 84 divided by 2. Okay, you can ignore all this other stuff. That was from another time. DMSBS is written down here at the bottom. Those are our steps to long division. This is a great way to practice long division. So the first thing I need to do is divide. 8 divided by 2 is 4. Now I need to multiply. 4 times 2, 8. S stands for subtract. 8 minus 8 is 0. B stands for bring down, so I bring down my 4. S, the second S, stands for start over. So 4 divided by 2 is 2. Multiply 2 times 2 and get 4. Subtract, get 0. I have a 0 at the bottom, and my quotient is full. And my quotient doesn't have a remainder, so 84 is divisible by 2. So 2 and 42 are factors of 84, which means the factors are, oh, where'd my page go? The factors are 1, 84, 2, and 42. So, is 84 prime or composite? It is composite. It has more than 2 factors. 97. I can multiply 97. I can multiply 1 and 97 to get 97, but there's nothing else that I can multiply together to get 97. There are no other factors, so it's 1 and 97 is it, which means it's a prime number. Number 19, circle the prime numbers, cross out the numbers that are composite or neither. All right, let's start at the beginning with number 1. What do we know about number 1? Number 1 is the only number that is not prime or composite, so it is neither. So we're going to put an X through it. Number 2, what are the factors of 2? 1, 2. That's it. It only has 2 factors, so it's prime. It wants me to circle the prime number, so I'm going to circle it. Number 3. 1 and 3 are the only factors of 3. There are no other numbers that multiply together to get a product of 3. And I can't divide 3 evenly by any other number without a remainder. So it is prime. Number 4. 4 has the factors of 1, 2, and 4. So since it has more than 2 factors, it is composite. So I'm going to cross it out. 5. The only factors of 5 are 1 and 5, so it is prime. What about 6? What are the factors of 6? 1 and 6. Are there any other numbers that multiply together to get 6? 2 and 3. So since it has more than 2 factors, it is composite, and we put X's through composite numbers. Number 7 only has 2 factors, 1 and 7. So it is a prime number. 8 has factors of 1, 4, or 1, 2, 4, and 8, because 2 times 4 equals 8. So it is composite. 9 has factors 1, 3, and 9. 1 times 9 is 9. 3 times 3 is 9. So it's composite. 10, you can multiply 1 times 10. You could also multiply 2 times 5. So the factors are 1, 2, 5, and 10. Since it has more than 2 factors, it is composite. Okay, I'm going to go through the next row and just circle and show you which ones are prime or composite. All right, 11 is prime. 12 is composite, 13 is prime, 14, 15, and 16 are all composite. 17 is prime because the only number that 17 is divisible by is 1 and 17. 18 is composite because it has factors of 1 and 18, but you can also multiply 6 and 3 and get 18. So since it has more than 2 factors, it is composite. 19 is prime. The only factors of 19 are 1 and 19. And 20 is composite. 20, because it ends in a 0, you could divide it by 2 or 5 or 10. So it's going to have all of those numbers as factors. So since it has more than 2 factors, it is composite. Are you sick of me saying prime and composite yet? Prime, composite, prime, composite. Say it 10 times fast. It's kind of hard. All right, I'm just going to go through and do the rest of them, and then you can check your work. So for that row, we only had 2 prime numbers, 23 and 29. The rest were all composite. For that row, 31 and 37 are the only prime numbers. The rest are composite. For that row, 41, 43, and 47 were prime. The rest were composite. I want you to notice something. Look at all the numbers that are circled. They end in 1, 3, 7, okay? So if a number ends in 1, 3, or 7, there's a good chance that it's a prime number. There are a few exceptions. 19 is also prime. 29 is prime, but 39 and 49 are not. So the only ones that end in 9 that are prime are 19 and 29. At the top, 2, 3, and 5 are all prime because there's no other numbers that multiply into 1, 2, 3, or 5, but 1 and 2, 1 and 3, and 1 and 5. But any other time where you have a number that ends in a 2 or 5, it is composite. So what you can start to do is you can start to memorize what numbers are prime numbers. So anytime you are asked to decide if a number is prime or composite, you just know it. You don't have to do any work. You can just pull from your memory and know that 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, so on and so forth. Those are all prime numbers. Okay, but look, most of the time, except for 27 and 33 and 21, they're a common trend that if it ends in a 3, a 1, or a 7, it's going to be prime. There are a few exceptions. Okay? There are a few exceptions, so pay attention to those. Number 20, write a prime number that is greater than 50. Okay, so it needs to be a prime number that is greater than 50. Well, we just said that if it ends in a 1, a 3, or a 7, there's a good chance, not always, but there's a good chance that it's going to be prime. So let's just try some numbers. Let's try 53. Because 53 is greater than 50. Can I divide 53 by any number and get a whole number with no remainders? No. Okay. Do any other numbers multiply together to evenly get 53? No. So 53 is prime. There are a bunch of other ones. Those are just the ones that's just one that I came up with. Okay? The one that you come up with might work too. Write a composite number that is greater than 70, 21. Okay, so I just need a composite number. That means it has more than 2 factors that is greater than 70. Well, there are a lot of them. Okay, I'm going to just pick one. 72 can evenly be divided by 2. 72 divided by 2. 7 divided by 2 is 3. 3 times 2, 6. Subtract 1, bring down by 2, 12. 12 divided by 2 is 6. So 2 and 36 are factors of 72, which means it has more than 2 factors because 1 and 72 are also factors. So it is composite. All right, that is all for the independent practice for today. You need to now go and do the homework. I will post the answer key to the homework on Classroom Dojo for you to check. If you need help or you need more practice, let me know so I can give that to you, okay? I'll see you guys tomorrow.